as we develop our understanding of functions, one of the tools that we're going to want is the ability to combine functions. The first way we're going to discuss of combining functions is an operation called composition. In composition of functions, we apply one function to the results of another function. So we use the symbol circle. It's a small open circle written between the names of two functions, which we read as f composed with g. That's a new function, such that if we apply f composed with g to x, that's the same as applying g to x and then applying f to that result. Another way that we can interpret this notation is as saying f after g, meaning apply g and then apply f to the result. So how do we actually do this? As a quick note on notation, we have this open circle to denote composition. We use a small dot to denote multiplication. Make sure that when you're reading your own writing, those two symbols are distinct from one another. I sometimes see students writing this symbol as a small circle. Make sure that, at least if composition is in play, your multiplication dot is filled in and your composition dot is empty. So how do we apply composition? Let's see a short example with a function presented as just a list of pairs. Here the function f consists of these four pairs, and the function g consists of these four pairs, and we'd like to take f composed with g of 2. So that means f of g of 2. So first we take g of 2. So looking in G, we find 2 in the first space. With input 2, G gives output 1. So G of 2 is 1. Then we apply F to that result. F of 1, we find 1 in the first place. That gives output 4. F of 1 is 4. So F composed with G of 2 is 4. I see there's a typo here. This should be some different number. Let's say 3. F composed with G of 3, that means F of G of 3. So to take G of 3, that's 4. And then F of 4, that's 2. So F composed with G of 4 is 2. And now order matters here. So if we take G composed with F of 3, that's G of F of 3. Well, F of 3 is 3. And then G of this 3 is 4. So G composed with F of 3 is 4. We can do composition of functions with a function just given as the pairs. We can do composition of functions with functions that were presented as graphs. So here we have two functions presented as graphs, and we've got some pairs that are on the graphs that are just kind of highlighted with dots for us to make them easy to find. Right, so we have on the graph of f, we have the points -1, -2, um, 1, 3, and 3, 3. On the graph of G, we have the points -2, 3, 1, 1, and 4, -1. So if we want to take f composed with g of 1, right, that'll be f of g of 1. And then g of 1, we'll look and see this point has x coordinate 1. Its y coordinate is also 1. So g of 1 is 1. And then we'll take f of the output of g. This point has x coordinate 1. Its y coordinate is 3. So f of 1 is 3. F composed with g of 1 is 3. F composed with g of 4, that's f of g of 4. To take g of 4, well, this point has x coordinate 4. Its y coordinate is -1. So g of 4 is -1. Next, we'll take f of this -1. And this point has x coordinate -1. Its y coordinate is -2. So f composed with g of 4 is -2. Now we're going to take g composed with f of -1. So that's g of f of -1. For f of -1, well, this point has x coordinate -1. Its y coordinate is -2. So f of -1 is -2. And now we're taking g of this -2. This point has x coordinate -2. Its y coordinate is 3. So g of -2 is 3. Thus, g composed with f of -1 is 3.